So in this question from the study set, we're going to look at the role of individual photons in human vision. So I looked up in some biology textbook and I learned that an individual cell in the eye, say one of your rod cells, which are the cells that collect light and turn them into electrical impulses and send them to your brain to help you to see. So an individual rod cell in the human retina needs to record a certain minimum amount of energy in order for it to decide that it has actually seen something real. Now the question we're going to ask is, how many photons does that actually correspond to? So if it receives enough energy, it will fire a nerve signal to the brain, and your brain will decide that that particular rod cell or cone cell saw some light, and it will possibly enable you to see it. If it didn't receive that much energy, the brain just screens it out and it doesn't see anything at all. So this minimum energy, or threshold energy, is about 10 to the minus 18 joules. So you can go and look this up and find out exactly what kind of cell this is for and exactly what wavelength. So let's imagine that this is the threshold that is required at a certain wavelength, and let that certain wavelength be the part of the spectrum where the human eye is the most sensitive. So at the most sensitive region of the spectrum, so the human visual spectrum ranges from about 400 to about 700 nanometers. Right in the middle there is lambda of about 550, which is often regarded as the peak of the visual sensitivity. So at lambda of 550 nanometers, what is the number of photons that we need to generate 10 to the minus 18 joules? Well, let's ask what is the energy of a photon. So energy of a photon is hf. This is Planck's constant, and this is the frequency. C equals f lambda, we know from the speed of light equation. Frequency, and here's our wavelength. So we can substitute this into here. So E phot equals hc over lambda. Now, if we want to know what the energy of this particular photon is at 550 nanometers, let's just stick the numbers in. So we've got 6.6 times 10 to the minus 34 joule seconds times 3 times 10 to the 8 meters per second divided by 550 times 10 to the minus 9 meters. Now you'll notice if we just look at the units, I did happen to put them in here for a reason. We'll see that the meters cancel. The seconds cancel with the per second, and we're left with the units of joules. So all of the units here were correct. That's just worth checking once in a while. So if you put those numbers into your calculator, as I did, you'll probably get about 3.6 times 10 to the minus 19 joules. So we can see, interestingly, that one photon doesn't deliver enough energy. So if one single photon strikes one single rod cell, your retina will not even notice it, which is kind of interesting because maybe that's some way of screening out noise or regarding only real bright light as being real. So let's find out how many photons would be required. So number of photons is just going to be the energy required, energy threshold divided by E phot, which is pretty straightforwardly this number up here, 10 to the minus 18 divided by 3.6 times 10 to the minus 19, which gives 2.8. Of course, you can't have half a photon or 0.8 of a photon. You can only have 3 photons. So this tells us that the minimum number of photons that one single sensitive cell in the eye has to receive in order to send a nerve signal and say, I see light, is about 3 photons.